So good afternoon, everyone. So yesterday we were discussing about the Delaunay's triangulation and the Voronoi diagram, which is the basis of all the triangulations that has happened. So today we are going to discuss an algorithm which was developed by Watson and Boyer. And this algorithm actually works for refining the Delaunay triangulation even further with respect to the type of meshes or the type of tessellation that we generate. So the difference between Voronoi and Delaunay was I explained yesterday, where Voronoi basically gave the idea that a surface can be divided on the basis of seed points, whereas Delaunay's idea basically converted those seed points as your nodes or your vertices, and using the smallest possible surface area, that is a triangle, they started developing the concept of triangulation. But the problem with Delaunay triangulation is that sometimes what happens is the surfaces that you generate with the seed points that you insert, it makes the surfaces very big. So the refinement of the surface becomes a very important aspect when you go for tessellation or triangulation. So Watson actually came up with a very simple solution which actually helped to refine the whole algorithm of Delaunay by using a very simple concept. So what they did was they said that once the basic tessellation has been done on the surface, you simply bring and insert a new seed point. This is a new seed point. And this seed point is actually going to be inserted. This seed point is actually going to be inserted randomly wherever you want. You can insert the seed point. A large surface area or a small surface area doesn't matter. If you feel that there is any critical feature on your surface which needs to be finely meshed, you can introduce a seed point in that surface patch also. So it becomes a user-defined function, the introduction of seed point, where you can define the seed point as per your own requirement. Now, once you introduce the seed point, you have to check all the triangles which are either adjacent to that seed point or the triangle on which the seed point has been introduced. So once I introduce this seed point, I have to check all the adjacent triangles. So what are those adjacent triangles? So this is the triangle 1. This is triangle 2 because triangle 2 के ऊपर ही seed point lie करता है. So we are not going to be too much bothered because this is triangle 2. This is triangle 3. This will be triangle 4. This is triangle 5. This is triangle 6. This is triangle 7. This is triangle 8. So this seed point is actually now near to 8 basic triangles. So the first thing that you need to do, again, I'll just repeat myself. The first thing that you need to do in Watson algorithm is after Delaunay triangulation has been done, you simply introduce a new seed point. And once you have introduced the seed point, you have to check for all the triangles which are adjacent to those seed points or the triangle on which the seed point is going to lie. So once we did that analysis, what we find is that there are 1, 2, 3, 4, 5, 6, 7, 8. 8 triangles which are adjacent to this seed point. Now what we need to do is we have to draw the circumcircles. We have to draw the circumcircles for all these 8 triangles. We have to draw a circumcircle for all these 8 triangles. And once we have done that, what we need to identify is that in how many circumcircles this seed point is going to lie. In how many circumcircles this seed point is going to lie. So as you can see, this is the triangle. This is the triangle. And once you have plotted the circumcircle, the triangle is lying within that circumcircle. The triangle is lying within that circumcircle. Okay, so this is the circumcircle. So this becomes the darked area. This becomes the marked area. Now this triangle is going to be affected. Similarly, we have this triangle whose circumcircle has been plotted, but in its circumcircle, this point doesn't appear. The seed point doesn't appear. So this seed point is not considered. So this triangle is not considered. Similarly, we go to this triangle. When we plot the circumcircle, this point is coming inside the circumcircle. This point is coming inside the circumcircle. So again, we mark this triangle. We have marked this triangle. Now, the next triangle that we are considering is this triangle. We plotted the circumcircle and the point is beyond that circumcircle. So this triangle is not considered. So in this way, we will check for all these 8 triangles which are adjacent to this point and mark out that triangle which is going to be considered in our study, and mark out those triangles which are not going to be considered in that study. So we have marked these triangles out. Now, once we have marked these triangles out, now what we need to do is we start with the evaluation part. We start with the evaluation part. So what is the evaluation? So the evaluation is that this seed point is already there and these triangles are getting affected by this seed point. So what we will do is the nearest edge of that triangle to the seed point, the nearest edge of that triangle to the seed point will be considered. So this is the nearest edge to the seed point of this triangle, and this is the nearest edge of the seed point of triangle 2. So this is triangle 1 and triangle 2. So we have taken the 2 nearest edges to the seed point of those triangles which are getting affected. So what we will do is we will eliminate this edge. We will eliminate this edge completely. We will eliminate this edge completely, and all those vertices, all the vertices which are affected by this elimination, all the vertices which are affected by the eliminations are now going to be joined with the seed point. All the vertices which are affected by the seed point are now going to be joined to the seed point. So how we are going to do that? This has been joined. This has been joined. So this becomes your first circle. This is joined. So this becomes your second triangle. This has been joined. This has been joined. So this becomes one triangle. This becomes one triangle. This becomes one triangle. So the refinement has taken place. So rather, instead of having 2 triangles, now you have 5 triangles. So this is how the Watson's algorithm actually works. अब अगली जो एल्गोरिथम है ये पूरी की पूरी हाइपोथेटिकल एल्गोरिथम है. This algorithm is completely hypothetical and it basically depends upon your analysis of how the meshing process will start. Now, once you have got a simple surface, let us assume you have got a simple surface. बहुत ही simple एक surface लेते हैं, एक rectangular surface. Now tell me from where the meshing will actually start.
Vertices, boundaries.
There are 4 vertices and there are 4 edges. From where will the tessellation process start? Any idea?
Triangular नहीं बनाना पड़ेगा.
But where will the seed point first originate? Triangle बनाने के लिए you need to create a seed point. So where will that seed point originate?
Anywhere inside.
So where will you decide? Where will you decide?
Top left corner, sir.
There is already one seed point over there, which you call as a vertex.
Center. Center.
Which center?
Center of the rectangle.
There is nothing called center of the rectangle. The center will be the
Diagonals.
diagonal center.
Yes.
ठीक है? The center will be diagonal center. Okay. So somebody says over here, है ना? Now what I say is, I don't want to create a vertex over here. I want to create a new seed point over here. Am I wrong or right?
Yes, sir, we can make, sir.
So basically the introduction of seed point becomes random, first of all, and user defined. It becomes random and user defined. So this algorithm that I'm talking about, which is triangulation with advancing front, basically it works on the simple principle that you are going to create a grid which is going to have either a triangular element or a quadrilateral element. Okay? Basically we'll be having a triangular element. Okay. Then what it says is that domain boundaries are actually initialized with linear curve, having nodes and edges that will form the front. So what it is saying is that every time when you start the process, you have a point, you join those points, and now what you have got is fronts. This is one front and this is another front. Edges are going to form your fronts. Okay. So now based on the fronts and the surface normal of that front, you can actually go on progressing, creating new internal nodes, and a triangular element is going to be generated because of that node. And the location of that node has to be defined using some set of criteria. And every time a new front is going to be generated. Now let me give you a basic example of what he is saying. Now, what we did was the first node that we assumed, was this. Let us say the second node is over here. The second node is over here. Now this front is going to move towards this. So what will happen? You will create a new element like this. You will create a new element. So what has happened to this front? This front has actually now propagated into two different fronts. So every time a new element is brought into picture, a new node is brought into picture, a new element is going to be created, and the front means the edge which is progressing forward. That front is now going to create a new internal boundary, and the algorithm will keep on continuing until there is no space for the front to continue, or the last of the spaces has also been defined. So the whole idea that the front is actually moving is basically dependent on what? The idea that the whole front is actually moving forward is actually dependent on what?
Nodes.
Nodes. Definitely. So as I said, putting the node is whose propagative? Your propagative. So once you put a node, now you have to see whether the front that is advancing continues to advance in a specified manner or a specified path, or it can be going in any random direction also. So there is no set of rules in this algorithm which tells you that if you are like moving in this direction, then you keep on adding nodes in this direction only. There is no set of rules for that. The second node can actually be put over here also, because you have one node over here and one node over here. So you can form this triangle. And then what you can do is you have one edge over here and one edge over here. You can create this triangle. Understood? So every time you have to think very carefully how the front is going to proceed. So you have to first see where the front is right now, and based on that, you have to decide where you will put the next node. So what is the decision criteria? So the decision criteria was actually based on how the two edges, ones which are going to be generated when the first triangle is created. So one triangle will be the boundary, and the two other edges will actually work as the expansion edges. Like from the example again, I'll just explain. So anyhow, if I start, I need one edge to start. I need one edge to start. So the moment I put one point over here, I put one point over here. So this becomes my boundary. So this boundary that is going to be created has to be thought of very carefully. Now the second node, where do I put my second node? I can put my second node here also. So rather than having a very definitive edge, I have got this edge. So how do I decide where the edge is going to be, and how to move, basically, how to move my front is what is going to be discussed. So what these people actually came up with, this is a completely empirical model. This is completely empirical model where the mathematics is actually defined more with the application of an individual case rather than a generic case. It is more like an individual case scenario. So what happens is the front is updated. The front is updated. Okay. How they are going to be updated? Well, once you move it over here, so your whole idea now goes over here. So this was the front one. Now this becomes front two. So the front has now moved forward. So the front has moved forward. So the edges that we are taking into consideration earlier, these edges are removed from the record. Now what are the edges that are available? These two are the edges that are available for the next analysis. So every time you move forward, you are deleting the previous data and adding on the new front. Now, how to define the front? So what they did was they assumed an angle. They assumed an angle. Basically, this angle is called alpha. This angle is going to be called alpha. And what they thought was that this alpha can have three basic values. Either alpha can be less than 90, alpha can be equal to 90 and less than 120. Okay. Or alpha can be greater than 120. So there are three values through which I can create a triangle. There are three values through which I can create a triangle. I can create a triangle which is less than a right angle triangle. I can create a triangle which is either a right angle triangle or which is less than an obtuse angle triangle, or I can make a triangle which is greater than obtuse angle but less than the 180-degree value. So how to put all these values into perspective, that is what I'm going to explain to you. So what they did was, the first assumption that alpha is less than pi by 2, that is 90 degree. So what this said was that this triangle, there are two fronts now, BC and CD. There are two fronts, BC and CD. Now these two fronts actually can close itself and form a triangle. The front can be closed and you can form a triangle. So now in this case, once you have formed a triangle, the front actually moves to AB and DE. The front will actually move to AB and DE. This is the first scenario. Second scenario is when the value of alpha is either 90 degrees or greater than 90 degrees, but it is less than or equal to 120 degree. When the value of alpha is greater than 90, but less than or equal to 120. In that case, it is not possible to create a triangle by simply joining, because the surface area will be huge. The surface area will be huge as compared to an acute angle triangle, So what they said was, in this case, you need to introduce a seed point. You need to introduce a seed point which joining with the original base, This is your original base. Point C is your original base about which the angle is being evaluated. So joining with respect to which there are two triangles whose own individual status will be acute angle. Whose own individual status will be acute angle. So now you have got the similar condition as in condition 1, where the angle is acute. So simply what you do is you join these two and you create two triangles, and the front actually changes over here and over here. So the front actually changes. Now, in third case scenario, when the angle is actually greater than obtuse angle, when the angle is greater than obtuse angle, that is, angle is greater than 120 degree. Now, in that case, what is bound to happen is that you have one line over here. Now you need to introduce a point somewhere. This is the seed point. You introduce this seed point somewhere, and this is all inside the surface boundary. This is not going outside like this. I is not over here. I is somewhere over here. I is somewhere over here. So I always remains internal point, which is going to be generated within the boundary domain. Okay, so now what you do is you create a new seed point, and what you do is you simply join the line that is extending or creating the obtuse angle. So you start to create small triangles and basically change the direction of the front as it is moving in different directions. Now, what is the sequence of operation? What will be the sequence of operation? The sequence of operation is not defined, but generally what this algorithm actually works about is that if you have this condition, try to convert this condition into this condition. And similarly, if you have got something like this, try and convert back this into the first condition, because first condition is something which is very simple to understand and simple to implement without any addition of a new point. New point means new data. New data means storing in more number of information. So based on these three conditions, the whole algorithm is further subdivided. The point now comes, you understand that there are three basic criteria, and in two of those criteria you need to put an internal seed point. So where do I put that internal seed point? Because I need to have a proper location of that seed point where I can put a node and get the data sorted out. So for that case, they came up with a small formula. They came up with a small formula where this is the formula. And what they have tried to explain over here is the distance or the length of the fronts at different planes. So when you are talking of creating a plane with respect to this and this, all the connectivity factor is taken into consideration. And similarly, the angles with respect to which the new boundary fronts will be generated, because if I create this line, definitely this front is already there, and if I create a line, I am creating a new front angle. Similarly, it goes over here also. So they came up with a formula, and they also came up with an empirical relationship of beta and gamma also. The empirical relationship of beta and gamma also. So you can see the value of beta and value of gamma. So they came up with an empirical relationship of beta and gamma also, where beta is going to lie between 1 by 5 pi and 2 pi minus 1 by 5 pi. This is the range for beta, and gamma with 1.5, 1 by 5 pi. This is an empirical chosen position, and as a result, what you do is you take basically gamma is 1 by 5 pi, and you simply draw a line, and once the line has been generated, you connect the other node also. So this is how you basically work with the system. Now, when you are trying to create an internal point, only 2-3 basic points have to be taken into consideration. The first point that you take into consideration is that the point has to lie inside the boundary domain. It cannot go outside the boundary domain. Then the node that you are trying to create, it should be within a specified limit means if I have, say, a triangle over here, and if I have a point over here, I cannot put a point over here like this. I cannot put a point like this, है ना? Because this distance is going to be very small and these two distances are going to be huge. So I need to define a proper condition for adding a new point, for putting up a new point. I simply cannot put a new point which is very close to the earlier existing or already existing node. So that I have to keep in mind. And if a triangular element already has been created, like say this is your surface and you have already created a triangular element initially, the new node cannot be inside that triangular element. It has to be outside the triangular element, but within the boundary of the original surface. It has to be outside the triangular element, but within the boundary of the original object. So these are the 3 points that you need to remember. So once you have done that, you simply prepare a node and a connectivity list, and the front actually moves forward as per the nodes are moved forward. And this procedure continues until you cannot put another node due to the condition that I have just explained, that the two nodes should be at a distance which is fair enough. So you define already when you put a node, that node has to be, say, the node has to be at a distance, should be at a minimum distance of, say, like 0.5 mm from each node. So once you put this condition and you see that the node cannot be further put, that means your triangulation is complete. This means that your triangulation is complete. So this is the end of today's lecture. So